and welcome to this very interesting project of rainfall prediction. So this is a classification problem that we'll be solving through machine learning. We will be using a random forest classifier for this, and the main concept that we'll be looking in it is the pipeline concept. So we'll be ignoring the other things and mainly focusing on the pipeline. So let us see how it is done. I'll be putting this project in the GitHub also, so you'll be able to download the code, and I'm sure you'll get something to learn from this. So we have opened the VS Code. Let us open the folder here. So file, new folder. Now you can, I have made one folder with the name of rainfall prediction classification. I'll open it. Here I have the weather data. This is my CSV file. So I have already made this program once, so I will be demonstrating it for you. I do hope that you'll get something to learn from this. Mainly our focus will be on learning, on implementing and learning the pipeline, how exactly the pipeline is happening. So let us begin with this. First of all, we will make a Jupyter notebook, not Jupyter notebook, rather IPYNB file. So I'll make it as rainfall prediction dot IPYNB. Here we have. So let us begin with the coding. First of all, we have to import the libraries. So import pandas as PD, import numpy as NP. This is done. Now we'll read the dataset. Df equals to pd dot read CSV, and here we have to put the name of this, weather aus.csv. Okay. So I have my data frame. Let us have a look at this data frame. Now this is a very interesting set of data. We are having date here, location here, minimum temperature. We have various type of data, means some missing values are also there. So we'll see how in pipeline it is happening, a very basic program. Now here this we have to handle all these things. Our target variable is rain tomorrow. This is the things we have to identify. Generally in the business problems, these are already known to us. So this is a classification problem, and my target variable is rain tomorrow. Okay, so now what we have to do, first of all I would like to know the dataset size. What is the size of my dataset? So I'll say df.shape. So there are 1,45,460 entries and total 23 features. Out of these 23 features, one is my target variable, which is rain tomorrow. We are clear here. Now let us see what kind of the data we are handling. So df.head. Okay, so df.info. So here you see I am having some float type variables are there, some object types are there. Here date is there. Now date is also an object type. In machine learning models name the numerical type values. So we have to handle them. We have to convert it into numerical form. We'll see how we can do that. First of all, let us check for the missing values. Let me put a markdown here. So checking for the missing values. See, to check, it is a simple code, df.isNull.sum. It will give me an idea. Okay, so these many missing values are there in each of the features. But directly by looking at the numerical values, I cannot get an idea like whether it is a large number or whether it is a small number. Should I drop it or should I keep it? Should I impute it? So to check that, I'll convert it into percentage form, and then I'll see means how much percent is missing. To do that, simply first of all I'll convert this particular table into data frame. Let me see. So df underscore null, I have given a new data frame name, pd.dataframe, and here I'll pass this, and I'll give the column names. So columns equals to I'll give it as missing values. Okay, let me see my null, this df underscore null. Okay, so see, it has become a data frame wherein this one of the columns is missing values. Now I have to add here a new column which will be showing me the percentage. To see the percentage, simply I'll add a new column, df of null dot percentage equals to df of. Now how do we calculate the percentage? First of all, I'll be needing the number of missing values. Next, I'll divide it by total number of entries. Total number of entries will be length of the data frame, and this I have to multiply by 100. I will multiply it by 100. There seems to be some error. Let me see what it is. Missing values. Okay, my mistake here. See, it has to be df underscore null, not df. This I am writing wrong. Actually, due to my habit, I always write it as df. Okay, so okay, now it is done. So df underscore null. This is not required. Okay, so I am getting these values now in form of percentage. I will sort it in descending order so that it is easier for me to check. So df dot sort underscore values. Now by what you want to sort? By, so I'll be sorting it by missing values. With reference to the missing values, it will be sorted. And do you want it in ascending or descending format? So ascending, I'll set it as false because I want it in descending. So I have it here. Now from the observation, I see that the top 4 means here the sunshine is missing 48% of values. Evaporation is missing 40% for cloud 3 p.m. and cloud 9 a.m. 38%. That is a huge amount of dataset that is missing. We'll drop all these features because they will not really, in this case, not really they will help in my prediction. Also, I want to keep this program simplified. Okay. Now rest of the features where I am having missing values, I am going to impute them. This will be done in the pipeline that we'll see as we move further in the project. Now, so first of all, let's see how to drop these. Simply we can give it by name also, but there is one more like it seems like a generalized method. We'll use that. So columns to drop. Now how to get those columns? That will be df of null. Okay, df of null dot columns, right? Now this will take all the columns names, but we don't want all the column names. We only want where there is a condition. What is the condition? That df of percentage, df of this percentage, this has to be greater than 30. So where my df of percentage is greater than 30, those values I want the columns. Okay, again there seems to be some error. Let me check it. Percentage. Okay, df of percentage, there seems to be some issue. Let me check it. Okay, see, again I said df underscore null, right? Not df. Okay, so now columns to drop. Let me see what columns I have got here. So these are the columns that I have to drop. Missing values. Sorry, something is wrong here. Percentage greater than 30. Okay. This should not come like this. Let me see. Let me restart the kernel first. See, whenever you are facing problem, sometimes it happens because some variable might have got misplaced or that thing. Okay, that is not the issue here. Let me check it. I have given it as a column here. This is wrong. Actually, this has to be given as index, right? I want those index where this is this will give me a true value. This overall feature, this will give me true value wherever percentage is greater than 30, and where df of null, wherever there is true, I want the index of that point. Okay, that is why I was not getting it. That is my mistake. Okay, see, when you are doing the program, these kind of errors, these kind of mistakes you will be making, so you have to check it out and you have to debug it. Anyway, so these are the 4 features that I will be dropping. Let me drop it. So here df dot drop. Now what columns to drop? What we want to drop? these are the columns, this I want to drop. Where I want to drop, these are columns. So axis I have to specify as 1. I want this change to be done in the data frame, so this is done. Now let me check it. df.shape. We see that there now our 20, we were having 23 features, now it has been reduced to 19 features. Well and good. Now a very interesting observation again. Rain tomorrow is also having missing values. So our target variable is also having missing values. Target variable is having missing values. This cannot be allowed. Target variable cannot have missing values. Okay. So what we are going to do, we will be dropping those entries which are having the missing values from the in the target feature, that is rain tomorrow feature. How to do that? Let us see. So df dot drop na, simple. Now where do you want to drop? There I have to give subset. What will be my subset? Rain tomorrow. Very simple. This is the subset. This is where, means wherever in the rain tomorrow you are having missing values, you drop those features, you drop those entries, you drop those columns, rows, sorry. Okay. So df equals to, again I want this change to come in df, so df. Let me see now df dot shape. Now you check it. Initially we were having 1,45,460 entries. Now I am having 1,42,193 entries. So some of the entries that were having missing values in the rain tomorrow feature, they have been dropped. Okay, that is good, well and good. Now let us proceed ahead. The rest of the missing values handling we'll do it after splitting in the pipeline. Now I'll handle the date feature. Why handling the date feature? Because it is like I have to convert it into to date time, so that is why. From the date I will extract year, month and the day of week, means which day which of the week, which day it is. Let's see how it is to be done. So df of date, first of all I have to convert it to date time. Here I have to use pd dot to underscore date time. Okay. Now to whom I have to do it? df of date. Okay. Okay. So here I have, it has been done, it has been changed. To check it, I can check it like this. df of means I want to check whether this has been converted into datetime format or not. Simply I'll use this column and I will write dot t types. It is m8ns. This means that it has been converted. Initially it was object, if you see in df.info. Now we will extract the month, year and day of the week from this one. So df of year, let us see how to extract it. Simply we will write df of year dot dt dot year, as simple as that. Similarly df of, what is the new column that I am adding? I am extracting it from the date, month. This will be added as a new feature in our data frame, that is equals to df of month. I'm sorry, this I made a mistake here. This will be df of date, right? Here also df of date dot dt dot month. Similarly df of day of week, what this will be? df of date dot dt dot day of week. Let us see. Okay, the code is executed. Let me see now whether it has worked or not. df dot head. We see there are new 3 features: year, month, day of week. So it has worked. Now this date is also remaining. I'll have to drop it. So I will drop this one. df dot drop. What I have to drop? Date. Okay. Where I have to drop it? In the columns. X is equal to 1. Axis, not x, axis. Axis is equal to 1. Now I want to save this data frame also. So df equals to df dot drop. This is done. Now let us see the shape. Okay, so now I have 21 features. Initially I was having 23, then it had reduced to 19. Now it has come to 21. Well and good. Now let me see again. Now in my target variable, which is the rain tomorrow, this is also of categorical type. Now see, in the pipeline we are handling the dependent variables, not the independent variables, not the dependent variables. That is, we are separating into x and y, right? So the things, the features in the x, that will be handled in the pipeline, but the features in the y, that is not in the pipeline, that we have to do it ourselves manually. So here simply first we'll see what are the values we are having here. df of rain tomorrow. So let me see, df of rain tomorrow. So df of rain tomorrow, let me see, df of rain tomorrow. Now dot value underscore counts. Let us check it. Now see, we are having no and yes. There are only two values, and one is no, one is yes. So directly we will do it by mapping. Okay, let us see how to map it. First of all, I'll take this column. This one means where you have to make the change. This is equals to, again it's the same thing, dot map, and in the map you have to pass it as dictionary. So here what is your yes? Yes to be replaced by, yes is to be replaced by 1, and no is to be replaced by, no is to be replaced by 0. Simple. Let us see if it works. Again we can run this one. Okay, so now it is 0 and 1. So this target variable, now this has been directly converted into numerical format. Okay, let us this one now we'll move ahead. Now let me put a markdown. So let us just check this data frame once more. Where is the code? Yes. So df dot head. Okay, I am having location, minimum temperature, maximum temperature, rainfall, wind gust direction, wind gust speed, and all these things are there. And I have my rain tomorrow here. All these things. Okay. Now now we will separate the dependent variable which is the target from the independent variable. So what is my x equals to df dot drop? What I have to drop? Obviously my target, because in my x I don't want this column to be there. Other than this I want everything to be there, and I have to specify the axis here. Axis has to be, because by default the axis value is 0, so it will search for this in rows. When we are specifying axis as 1, that means that it will search for this value in columns. So x is done. Now what will be my y? Y will be df of this value. Simply I'll paste it here. So I have x and I have y. Now I need to change it, now split it into train and test. Splitting the data into train and test. Let us see how to do that. It is simple. From sklearn dot model selection import train test split. Okay, now x underscore train, x underscore test, y underscore train, y underscore test, this is equals to train test split. Now we are passing x, we are passing y, random, we have to specify the test size. So test underscore size, that is equals to 0.2, random state. So random state, this let's put it at 0, and stratify equals to y. This we are using stratify. I am using because I am having an imbalanced data set. Okay, so this has been executed. Now let me see x underscore train. Let us see the shape. Okay. So we are having, okay, so 1,13,754. These many datas have come in xtrain, and total 20 number of features. I was having 21. One has gone into, one was my target variable. So well and good till here. Let me check for the train also. So x underscore train dot shape. So I am having 113754. Sorry, this is my mistake. Test. I'm checking for test. So 28,439 values. These are given for testing. Okay. Now we'll see how. Let us see the further steps. First of all, I need my numerical values and categorical columns, means values. That will put it, means what are list of my numerical columns and list of my categorical columns. Very simple way. Numerical underscore columns. This is equals to df dot columns. Now what columns? Here I'll specify select underscore d types and what kind of d types? Include equals to number. Let us see. Okay, this has worked. Similarly, I have to give cat columns. This here it should not be df, rather it will be x underscore train. I'll put it as x underscore train. So x underscore train, because we have splitted it, right? X underscore train dot select underscore d types dot include equals to object dot. So I have my numerical columns, I have my categorical columns. This is done here. If we want, we will just check it whether we got it or not, we captured it or not. We can check it. So these are the list of my numerical columns. I don't need to manually count how many columns are there. I can simply put it as length and it will show me the number of numerical columns. 15. I'm having 15 numerical columns. Similarly, for categorical columns also I can do it. Now here we will start with the pre-processing pipeline. Let us see now how it is done. From sklearn dot impute import simple imputer. This imputer I am imputing to fill the missing values. This will be handling for categorical values also, numerical values also. Second, from sklearn dot preprocessing import one hot encoder. In this project, all of the categorical features I'll be handling through the one hot encoder feature only, because as I mentioned before, my more focus is on demonstrating pipeline. Now from sklearn dot pipeline, I have to import pipeline. Again, from sklearn dot compose, I have to import column transformer. Okay, now let's see. First of all, I'll make a numerical pipeline. How to make it? Let us see. Numerical pipeline. And next I'll make categorical pipeline. Cat underscore pipeline. So first of all I have to give pipeline simple, and here also pipeline. I'm doing it parallelly. I hope that it will be better to understand. Just hoping that it will be better to understand, that's all. So pipeline. Now what I have to give here, I have to pass a list here. In pipeline we are passing a list. Now what is there in the list? First of all, I am giving an imputer. Okay, and what is my imputer? Simple imputer. And what is the strategy? Since it is a numerical, we will use the strategy as mean. Fine till here. In categorical, let me put this like this. In categorical, here again, here also I have to give imputer because I am handling the missing values. Here I am doing two things, handling the missing values, handling the categorical values. So first let us see for imputer. Just a minute. So okay, imputer, simple imputer, where strategy equals to, what is the strategy? Most frequent. I have a most frequent, that is we are filling it by the most frequent value, which is the mode. And what is the other thing? Encoder. I need an encoder also. So encoder is encoder first of all. So, and which encoder I am using? One hot encoder. One hot encoder. Handle just to, so that it is able to handle unknown values, it has to ignore. Okay, so numerical pipeline has been created, my categorical pipeline has been created here. It has been defined, basically the rules have been defined here. Now is my preprocessor. Let us see. Preprocessor. Preprocessor equals to column transformer. Let me put it in this way. So first I am passing, no, here my numerical pipeline will come, and what will be going in that? Numerical columns. Second, for categorical, cat underscore pipeline. This is my, not cal, it is my cat categorical pipeline, and here this is not this, this will be like this. Okay, and this has to go in brackets. Here also it has to come in brackets. Okay, done. So preprocessor is also done. Now here I'll be doing it on, I'll be doing a random forest classifier. I can do logistic regression also, but for now, just for demonstration purpose, I'll be using random forest classifier. This random forest classifier, it does not require scaling per se, so we are fine since we have not done scaling here. Let us see how to implement that. So from sklearn dot ensemble, import random forest classifier, model pipeline equals to pipeline. I have to make the, now I have to make the model pipeline. Now in the model pipeline, what is happening? Same way we had done there. First of all, my preprocessor will come, next my model will come. Okay, so preprocessor. Now what I have to pass here? Preprocessor. Then my model will come, and here I have to pass my model, random forest classifier. I'll give some of the values here because it will take some time, but it will get some good results. Let me put n estimators as 150. I'll give random state as 40 or 0, simply 0 is fine, and class weight equal to balanced. Okay, so here my model pipeline is also ready. Now I have to fit this pipeline on my train data. So let's go ahead. Model dot fit, model underscore pipeline dot fit. Here x underscore train and y underscore train. Now it has started to train the model. This will take some time. Let us see. Now, while the model is getting trained, there are few points that I want to tell you. See, in this project, what is happening? The train test split, now this missing values filling, it has been done in pipeline. There is a concept of data leaking. So you have to keep in mind that when we are doing this, when we are doing, when we are filling our, when we are handling our missing values, we are calculating the mean, median, mode, all this stuff. So this has to be calculated using the data of train values only. The test value should not be included in that. That is the reason we have first splitted it into train and test, and then we have means then we have created a pipeline for preprocessor, and then we had fitted to the model also. Now when we are evaluating, that time we are passing the train data set. So whatever the pre-processing data has been done on the test data set, that will be done on the train data set also, because of this pipeline. So let us wait for this. Okay, so our model training has been completed. It took a long time. It took 5 minutes 47 seconds. So that's a lot of time. But see, here a tree is formed. So we get a very clear idea, means how it has worked. Categorical columns, numerical values, it all went to random forest classifier. Here simple imputer had taken, one hot encoder work has been done. So it's very interesting, right? Now, so let us see the predictions now. We'll predict the value. See, y underscore pred. This is equals to model.pipeline model underscore pipeline dot predict x underscore test. Now see here, when we are passing this x underscore test, whatever feature engineering, whatever changes in the features has been done in the trained dataset, that will be done here also, simply in one line. We not need to do it on the test dataset separately. So this is the thing, this is the pipeline. Okay, now let us see the evaluation. So from sklearn dot metrics import classification report confusion matrix. Okay, let's see. So print, we'll just print the classification report. Classification report and /n here, sorry, comma. So classification report of y test and y pred. Similarly, print confusion matrix. So how to print that? Confusion matrix kiska, for what? For y test and y pred. Simply I'll copy it here and paste it here. let us see. So I got here classification report, I have F1 score, I have a recall for 0 and for 1. Okay, it is not a very good value, recall, but okay, for my testing for now it is a good thing. So we have successfully done this, and we have successfully implemented it through a pipeline. We tested it, and so I hope that you learned a lot of things in this project. It is a standalone project, means just to demonstrate the pipeline. Do let me know if anything is there, and we'll see. Thank you very much.